Last presenter tonight is probably one of the folks that is most looked forward to every year at NSAW. He probably holds the record for a number of times he's spoken at NSAW. This man may not need much of an introduction, but I'll do my best anyway. Nick Bond will be our next presenter. Nick is the principal research scientist with the Cooperative Institute of Climate and Ocean Ecosystem Studies at the University of Washington, and he is the climatologist for the state of Washington. We have Nick back every year because we really love to get excited about winter, and so Nick's going to be talking again tonight about the outlook for the 21-22 winter in the Pacific Northwest, and he's going to review a couple of the expected highlights for this year, including the highly likely La Nina that will be reappearing in the tropical Pacific, which is good news for winter sports enthusiasts. But it'll also represent the second back-to-back La Nina winter. And this one, we will have to sit to learn how these other winters particularly tended to play out. So Nick, thanks for coming back and speaking with us. Again, I'm always excited, and thanks for taking the time to get us stoked on winter.
Okay, thank you. And I will share my screen. And hang tough. Hello, slideshow. You should see a cartoon. I like to start with cartoons, right? And yeah, like Dallas said, you know, I've been talking to you guys for a while, and people of my, like me, sometimes are accused of double talk. And so you'll be the best judge of that when we're talking about the forecast and how great it was last year and that sort of thing. But anyway, let's go. So what I want to cover today, really, you know, in a whirlwind tour, is a little bit about last winter's weather. The idea, again, we're in a back-to-back La Nina. What does that imply? The actual forecasts for temperature, precipitation, of course, and just touch on a little bit something, the Madden-Julian oscillation, that is something we're starting to use and can take better advantage of in getting kind of an extended forecast. All right, so here we go. All right, the winter of 2021, here defined as November through March. I've got a couple of maps here, a temperature anomaly map on the upper left, a precipitation in terms of percent of normal on the upper right for the months of November through March. It was a little bit on the warm side overall for the Pacific Northwest. Where it was especially warm was in the lower elevations of eastern Washington. You might think, well, shoot, you know, there are no slopes there. But that is a source of cold air for the passes, especially Snoqualmie Pass. And so, you know, it's important to kind of consider what was happening there. For the Cascades as a whole, is maybe a little bit on the chilly side even. And then in terms of precipitation, again, the Columbia Basin was kind of on the dry side in the winter, but Western Washington and Northern Cascades did pretty well. Here, I'd like to pick up on what Matt was just talking about, and with regards to last winter, kind of what happened early in the winter until February. What is shown here for government camp near Mount Hood in Oregon, at roughly 4,000 feet or so. The temperature trace relative to normal is the upper chart. The accumulated precipitation relative to normal is the lower chart. You can see early in the year, it was a little bit on the warm side and so forth, kind of continuing into January. It was reasonably wet, but still it wasn't all that great conditions in terms of copious snows in the mountains. But then February came, and for what it's worth, it was both wet in terms of the accumulated precipitation here at government camp, but this was all across the Pacific Northwest. And here in terms of the temperatures, quite a bit colder than normal for an extended period. And then for what it's worth, yeah, this spring and summer happened when everything dried out, but that's a different story, different talk. Obviously, there were some impacts from all of this. This is especially in February when we had some low elevation snow on the west side of the Cascades, and in particular in the Columbia Gorge area and in Portland, that snow was followed by ice. You can see the snowman here in the lower right is reflecting that. And it was also reflected in some of the struggles the Department of Transportation had keeping the passes open. Here is a notice that they're closing Stevens Pass. I see a lot of cars there. It's 1 in the afternoon. How did those folks get home? Did they try to get home? Yeah, not clear exactly how that sorted itself out, but clearly there was lots of snow in the mountains, and some both good things and bad things that happened as a result. Just another perspective there, here going to Stevens Pass and looking at the snow depth from the start of December of last year, this blue trace, to the end of March. And can see that it was okay at the end of last calendar year, but and then in January we had a fair amount of precipitation, but still didn't really build up the snowpack. And then came February, where I got over 60 inches of snow in that month at Stevens, and that more than 60 inches, the actual depth increased by 60 inches. And that compares 2 years ago is the orange trace that actually did pretty well after the first of the year, but really got to a poor start. All right. You guys have, if some of you have attended this workshop before, you've seen me and then seen me trot out these 500 millibar anomaly maps. And, you know, yeah, it's jargon and all that, but I think there's no better way to explain what's going on. What I want to emphasize here is how consistent the overall atmospheric circulation has been the last couple of winters. This is for the winter of 2019-2020, with higher than normal heights, pressure aloft. This is at 500 millibars, about 20,000 feet, lower than usual heights over north central Canada. The implied flow is out of the northwest more than usual. So that was 2 winters ago. Last winter was kind of more of the same. And burn this into your retina, because I'm going to show you some forecasts for these kind of patterns here in a couple of minutes. Okay, like I said, you know, we had quite a summer, unprecedented heat wave, lots of fires, especially in Oregon and California. And that gives me a chance to kind of trot out this cartoon that I think I've used before, where we've got, yeah, La Nina again. And one of the reasons, well, what you can see here in the sea surface temperature anomaly pattern, again, temperatures relative to normal, for about a week ago, these blue colors show in the tropical Pacific, the eastern and central tropical Pacific, it's on the cool side. Along our coast, more off of California, it's on the cool side in the Gulf of Alaska. That's good news, because it is warm out in the central North Pacific. And if that warmth gets too close to our coast with a fair amount of the flow coming off the ocean, that can warm our temperatures. I don't think that's going to be an important effect this year. So La Nina, the official forecast here in terms of the probability of it, this was just updated this week, shows for the remainder of this calendar year into next year, very high odds of La Nina continuing. Just in the last week, it's been officially announced we're in La Nina conditions. Just it's weak intensity right now, but liable to strengthen some. And in the lower right, you can see what the various models are suggesting there in terms of the evolution of the tropical Pacific. And some of them are kind of keeping it about the same for the next few months. Others are cooling it off. As a group, they're bringing it into a moderate range. And so that's what the forecasts are reflecting. And we had a La Nina last year. And so some recent work that the Climate Office has done, and very kind of simple-minded stuff, was just look at what the weather was like in the second of back-to-back La Nina years compared to the first of those back-to-back ones. Turns out La Ninas happen in pairs like that, roughly 2/3 to even 3/4 of the time. So it's pretty common. What I show here in the table is for year one of a back-to-back La Nina on the left, and year two of the back-to-back La Nina on the right, separated into the kind of early in the cool season, October through December, and later in the cool season, January through March. This is in terms of temperature. And the idea is in the first year of La Nina, don't see a temperature signal very much at all early in the winter. But there is a cool signal. It's not guaranteed, but there is overall a cool signal in the fall, October through December, of the second year of back-to-back La Ninas. After the first of the calendar year, when La Nina normally kicks in, it's quite strong in those effects in the first year, a little bit muted in the second year of La Nina. So the term I've heard here and used myself, a kind of early to ripen, early to rot. So we may get off to a good start here, but conceivably the kind of cool wet conditions won't extend into March and April as much as they often do. Doing the same sort of thing for precipitation. There's a lot more noise in this signal, but the idea that the falls of the second of back-to-back La Ninas tend to be a little wetter, and after the first of the year, a little drier relative to the anomalies with the first year of the back-to-backs. So maybe we're off to a good start. All right, I want to briefly go through some of the model of results. Here you can see I obviously ripped off this cartoon, and don't tell anybody, but I didn't pay cartoonstock.com for the privilege of using it. So anyway. So what are these models forecasting? Again, what I'm going to have is two plots here. On top is the 500 millibar height anomaly pattern. And this is for the 3 months, November of this year through January of next year, of course. And on the bottom here is a temperature anomaly plot and a precipitation anomaly plot. And the temperature level that I chose was at 850 millibars, 5,000 feet. Maybe the models are probably better at forecasting temperatures aloft than at the surface. And moreover, this maybe is more relevant. So anyway, the forecasts are, again, like we've seen the last couple of winters, higher than normal heights or pressure aloft to our west over the central North Pacific, low heights, low pressures over west central Canada. The implied anomalous flow from the northwest, pretty good news. When you actually look at the temperatures and the precipitation, the temperatures on the near normal side from these models, but definitely on the wet side too. Let's look at the 3-month period of January through March, when normally La Nina has its most robust effects. And they're a similar sort of circulation pattern aloft. And here the model is as a group, and there's about 7 models that are all smushed together in making these forecasts, are suggesting maybe a little bit on the cool side, especially in the northern part of the Pacific Northwest. And again, wet, especially on the west side of the Cascade Crest, again, for this period, January through March. All right. One thing that I think is encouraging is what the models, the trend in the model predictions. And so what I want to kind of point out here is the model runs, again, I'm looking at 850 millibar temperatures, about 5,000 feet or something for November through January. The forecast from that group of models that was made in September had us a little bit on the warm side, but still not too bad. The latest forecast from October for the same period has us cooler. And so the models are kind of making it cooler and cooler in their forecasts. No guarantees, but it's a good sign. And then they are also suggesting that it's going to be on the west side. To give you a little bit more of an idea of how robust these forecasts might be, what I have here is six. For a minute, don't look at this circled one here, but 6 individual models of the precipitation anomaly forecast, again for November through January here. And with the blue colors showing in green showing wetter than normal. 4 out of 6 of those individual models are showing wetter than normal, not bad. It's not an overwhelming consensus, but there is a consensus of wet. And then obviously what that is consistent with the overall forecast, the group from the international multi-model ensemble, the European model forecast. All right, so how did we do last year? This is what the forecast was from October of last year for the 500 millibar pattern. Again, this higher heights pressures to the west, low over Canada. Apologies here that it's not the same kind of color, the scale and all that sort of thing. But this is what actually, the previous one is what was forecast. This is what happened. And so indeed, there were higher pressures to the west. If we go back, it's not an exact fit, certainly over Alaska and Western Canada, but still not bad. The idea here is that there was actually in the mean, and this is for December through February for what it's worth, this pattern implies anomalous flow from the northwest as forecast. Okay, one fly in the ointment having to do with any kind of forecast this time of year, and this is both for the weather forecast and for the seasonal forecast, is what's going on in the central, the West Tropical Pacific. There's still a lot of tropical cyclone activity there. This is a satellite picture from a week or 10 days ago or so. And what happens this time of year, there's a lot of these guys out there, they tend to recurve and get into the storm track, and just how strong they are, how much moisture they carry, and exactly what longitude they come in is really hard for our weather prediction models to handle. And so that means extended forecasts have been shown to have demonstrably less skill this time of year than other times of year, in large part because of this reason. And it could be a reason why we tend to see that our seasonal forecasts are kind of degraded this time of year compared to the middle of winter. So a caveat there, again, making excuses, double talk, whatever you want to call it. All right, let's go to the official forecast, and then I just want to touch on one little item, and then we'll be done here. Here's the official forecast of the Climate Prediction Center of NOAA, showing for November through January. There are equal chances of either below normal, near normal, or above normal temperatures, but they're catching on to the idea that the models are pretty emphatic about this, and given the La Nina that it has developed and is liable to strengthen a little bit on the wet side. If we look further into January through March, here the La Nina's effects with below normal temperatures, looks like there's higher odds than usual below normal temperatures and a continued wet signal, especially in Washington state. Okay, I'm just going to take a minute here and just what I want to do is whet your appetite for something maybe I'll talk about next year in more detail. I have a little bit more time, and that is something called the Madden-Julian oscillation, which is something kind of like the NSAW El Nino La Nina cycle, but on shorter time scales. And the idea that we can use this phenomenon to make forecasts between that weather time scale of out to a week or so, and kind of seasonal timescales. And the idea there is that as clusters of thunderstorms develop over the Indian Ocean and move eastward out over Indonesia and the Pacific Ocean, they have impacts on the circulation at higher latitudes in the same way that El Nino and La Nina does. And in particular, this cartoon here kind of shows, I'm not going to let you really look at it long enough to fully digest it, but as these clusters of thunderstorms move slowly from west to east, there are systematic patterns in terms of high and low pressure centers that develop. And we can use that to make extended forecasts, because this whole cycle is on something like a couple of months. And so if you see an MJO really starting to form in the Indian Ocean, you can make some pretty good projections about how it's going to evolve over the next month or so. And some work that I did a long time ago showed that in different phases of this MJO, there's different kinds of high and low pressure patterns that set up on average. And there can be, as a result, overall dry periods or wet periods here in the Pacific Northwest, these places where it's stippled is where the signal is statistically significant. And some later work that was done looking at Alaska weather has basically shown the same thing, that when you divide that MJO cycle into 8 phases, there's kind of a regular kind of progression of high and low pressure systems. Now, not every MJO event evolves in exact the same way. Some are faster, some are slower, some will wimp out before they get all the way to phase 7 or so forth. But it's still something that we can make hay of, and hopefully start bridging that gap between the weather forecast and the seasonal forecast. All right. So what seasons is getting off to a decent start, right? My lawn's greened up and everything. We still have a long way to catch up on precipitation, particularly east of the Cascades. There was some severe drought in eastern Washington this summer because La Nina is here and liable to continue. It means the second of back-to-back La Nina years, we tend to get an early start to winter. It's still kind of, the snow's not going to fly except at the highest terrain for a while. And so here, what I suggest you do is during this rainy weather that we have in the next week or two, adopt a storm drain. I get no greater satisfaction than clearing out the leaves of a stopped up storm drain in my neighborhood and watching all that water whoosh down. Admittedly, I've been married for 35 years, and so that's my greatest source of well, anyway, won't go there. And just the last thought there, that while I'm giving hopefully a optimistic and forecast that everybody or most everybody's pleased about, I just want to assure you that the Office of the Washington State Climatologist is not, in fact, in the pocket of the ski resort industry. And with that, thanks. It's easy to get a hold of the Climate Office if you want more information. I'm just going to leave this up for a second in case you want to look at it. But I'm going to stop sharing my screen so we can get this show on the road.
Nick, thanks so much. I always get excited about hearing about the winter from you. And it is even better when you get to deliver good news. While a couple questions are coming in here. One of the things that struck me last season, and it's not an uncommon event for us here, but we seem to have a fair number of really strong atmospheric rivers. And I was just kind of curious if you are aware of, or maybe you've done, any research in the number of strength of these events or the number of them that may be in any relationship to that NSAW phase?
Yeah, that's a good point. And I haven't directly done some of that, but what we do notice is that there are at least increased frequencies of moderate floods during La Nina conditions, and not every watershed is the same. Just like we know that in certain kind of storms, certain places are going to do better in terms of the snowfall and so forth. The same thing happens with these heavy precipitation events, and our very heaviest ones are with west-southwesterly flow, and that are kind of on the warm side. And so they're a mixed blessing. They deliver a lot of water to the mountains, but as Matt went over, there can be some real drawbacks to that in terms of the avalanche threat and keeping the passes open, flooding, all that sort of thing. And but that gave me an idea, and maybe next year I'll have a little bit better statistics kind of at hand about atmospheric rivers and how they varied over the years.
On a similar question, Kyle asked basically the same kind of idea, but convergence zones are a big part of our mountain meteorology here. Has anybody looked at convergence zones, their strength or frequency again in these kind of
that's a very insightful comment. And I would say that it's not just aloft, but we get more northwesterly flow at low levels that promotes convergence zones during La Nina years, not day in, day out. I couldn't hazard a guess on, exactly how many more, but I'm pretty sure there are more. And one of the things it gets kind of tricky to how do you count them and what qualifies as a convergence zone and so forth. But great point.
Let's see here. Doug asked, do you weigh one of the MGO index more than the others for forecasting purposes, like the RMM, OMI, or FMO?
Yeah, that's right. I like the one that comes out of the Australia group, the Bureau of Meteorology there. I think is they've done some of the groundbreaking work there. And for those that, obviously there's somebody here who's pretty well acquainted with the MJO. It turns out when the convection, especially during La Ninas, when the convection is enhanced over Indonesia, that's probably pretty good conditions for us getting more northwesterly or northerly flow and colder weather.
I got another one here, Nick. Mark Moore could not help but try to see if he could stump you. So what changes, if any, do you expect global warming to have on the strengths and durations of unusual NSAW events?
Yeah, that's a great question. And that is an area of active research. I was just looking up some of this, and the models, some of the climate models we're using for those projections are showing a weaker NSAW cycle. Some are showing stronger ones. I think the very most sophisticated models and the more recent ones with higher resolution are tending to show kind of a weaker cycle there, and a weak tendency to be in a slightly El Nino conditions more. The asymmetry in the tropical Pacific is not as great in the future, but it's still something folks are trying to figure out, because that would help a lot in making our seasonal forecast.
I think we've got time for maybe just two more quick ones. They're going to ask you to look deep into your crystal ball here in terms of long range predictions.
Okay.
This past summer was pretty warm and hot here in the Northwest, kind of had an abrupt end to our snow season. Any idea kind of what we have coming at us next summer?
Oh God. Yeah, no, one thing to keep in mind is that especially the heat wave we had was unprecedented. It's not like that's going to be the new normal. We're going to get, there's some of the temperatures we saw. And so I'm pretty secure that we won't have as intense a heat wave with global warming. They're going to the suggestion is they're going to come along maybe about every 10 years or so of that intensity. And we won't have as much of a drought. Especially what was weird about this drought was that we just had was how dry it was from spring into summer. And so that since that set a record, chances are that's not going to happen again. And so I think, the summer coming up is going to be more pleasant. And, here's hoping.
Yeah, I'm with you. I think my AC is getting a workout. Last question I've got for you here, Nick, is do you or the state climatology office have a email inbox for complaints about rain on snow events from skiers and riders? Somewhere where we can voice our displeasure with the deterioration of conditions.
Yeah, well, no, I've got we've got our spam filters, set up with that in mind. And yeah, and that's, cool and wet, oh, what could be better? But there's still going to be these warm events. And, especially, when the climate is warming. And one of the reasons that I think the Climate Prediction Center for this November through January period has kind of near normal temperatures is kind of recognition. Okay, La Nina would kind of tug us toward the cool side, but the overall trends maybe are tugging us to the warm side, and it's kind of a wash. And so the idea is there's still going to be rain on snow events, and hopefully, maybe some of them will let's look at the bright side and stabilize the snowpack, and maybe not have the same kind of avalanches we'd otherwise have.
Let's hope so. Nick, thanks for sharing the good news with us. If you have a moment, I think there's one more question in the Q&A that if you have to type an answer, that would be great.
Yeah, I'll go there. Thank you.
Excellent. Thanks, Nick. So again, thank you all for joining us tonight. I'd like to remind you that there's a ton of gear in our NSAW sweepstakes, and you'll be open to you until Thursday, October 21st. Before you leave us tonight, we'd like to encourage you to stay connected with your local Avalanche community this winter. You can remain engaged by becoming a member of NWAC, attending one of our numerous Avalanche education programs, and even by submitting public observations on our website. If you're out in the mountains this fall or winter, we really appreciate you taking the time to let us know what you find and see. You'll see a link to submit observations in the chat. We also really want to hear from you and give us your feedback. We have a quick survey that'll be dropping in the chat right now. It takes about 10 minutes for you to fill out, and it impacts how we're planning for next year's NSAW. If you fill it out, you'll also be entered to win some really cool gear. The survey link will also be included in tomorrow's email, along with all the NSAW recordings. Once again, we'd like to thank Outdoor Research for sponsoring this evening, and to all our partners and sponsors for supporting us here at the Northwest Avalanche Center and the local backcountry community. We will be sending out an email tomorrow for you to access all of these recorded sessions. We look forward to seeing you in the mountains this winter, and we hope you have a great evening. Thanks for coming and attending with us.